T of n is equal to 1 plus alpha 1 into 1 plus alpha 2 into 1 plus alpha 3. That is P1 to the power of alpha 1 into P2 to the power of alpha 2. S of n is equal to, you know the formula, P1 to the power of alpha 1 plus 1 minus 1 divided by P1 minus 1 into P2 to the power of alpha 2 plus 1 minus 1 divided by P2 minus 1. Hello dear students, welcome to this session of mathematics class. I am Mr. Niranjan, faculty, Department of Mathematics, Vidhyaashram PU College, the Temple of Excellence. So in my previous class we have discussed regarding the canonical representation of a number and the sum of positive divisors and the number of positive divisors. Now in this session also I will take few more problems based on those concepts. Now let us come to the first problem. What is the problem? Give the canonical representation for the following numbers. Now let us consider the first one, 96. Now let us express this as the prime factors. So now 96 can be written as, let us divide from 2. So 2 4s are 8, 1 remainder 16, 2 8s are 16. Okay, so 2 4s are 2 8s are, that is 48 into 2 is 96. Again you can take 2, 2 2s are 2 4s are, again from 2, 2 1s are 2 2s are, again from 2, 2 6s are, again from 2, this is equal to 3 times. So you can write this as 2 to the power of 1, 2, 3, 4, 5. So 96 can be written as 2 to the power of 1, 2, 3, 4, 5, 2 power 5 into 3 power 1. So this is called the canonical representation of the number 96. This is of the form as we have studied in the previous class. This is nothing but P1 to the power of alpha 1 into P2 to the power of alpha 2. So the canonical representation of 96 is 2 to the power of 5 into 3 to the power of 1. That's it. Okay. Suppose if you want to find, in the last class we have discussed regarding finding the number of positive divisors and the sum of positive divisors. Suppose if you want to find the sum of number of positive divisors, the number of positive divisors are 3Tn, that is nothing but T of 96 is nothing but 1 plus alpha 1 into 1 plus alpha 2. And the sum of positive divisors is given by S of n is equal to P1 to the power of alpha 1 plus 1 minus 1 divided by P1 minus 1, etc. So using this concept we can find the number of positive divisors and the sum of positive divisors. But here what is required to find is just we have to represent the given problem as the canonical form. Now let us come to the next problem, 156. Let us represent 156 in the canonical form. Now 156 can run as 156. Let us start with 2, that is nothing but 2 7s are 14, again 2 8s are 16. So you cannot divide from 2. 2 3s are 6 and 18. Again 2 3s are 6, 2 3s are 6, 1 remainder, 2 9s are. Again from 2 we cannot divide, let us take 3, 3 1s are, 3 3s are, again from this you can't do, so this is 13 1s are, that's it. Okay, so you can divide from 2, 2 7s are 14, 1 remainder, 16 is there. So then 2 8s are 16, again you can divide from 2, 2 3s are 6, 1 carry, 1 remainder, 18. So 2 9s are 18, again we can't divide from 2, let us take 3, 3 1s are, 3 9s are, again 13 is a, you can't divide 13 by any other number, so this can run as 13 ones are. So therefore this can run as 2 to the power of 2 into 3 to the power of 1 into 13 to the power of 1. So therefore 156 can be written as 2 to the power of 2 into 3 to the power of 1 into 13 to the power of 1. This is the canonical representation of this number. Okay. Now suppose if you want to find the number of positive divisors for, let me find out the number of positive divisors. This is of the form P1 to the power of alpha 1 into P2 to the power of alpha 2 into P3 to the power of alpha 3. Here what is P1? P1 is equal to 2, P2 is equal to 3 and P3 is equal to 13. What is alpha 1? Alpha 1 is equal to 2, alpha 2 is equal to 1 and alpha 3 is equal to 1. Suppose if you want to find Let me solve for the number of positive divisors. Suppose if you want to find the number of positive divisors, that is T of n. T of n is equal to 1 plus alpha 1 into 1 plus alpha 2 into 1 plus alpha 3. That is the number of positive divisor. Number of positive divisors. So therefore, T of 156 is equal to 1 plus alpha 1. What is alpha 1? Alpha 1 is 2 into 1 plus alpha 2 is 1 into 1 plus alpha 3 is also equal to 1. This is 3 into 2 into 2. 3 2 is 6 2 is 12. So the number of positive divisors, if you want to find for this, is 12. And the sum of positive divisors, for this we are going to use the formula for the sum of positive divisors. S of n is equal to P1 to the power of alpha 1 plus 1 minus 1 divided by P1 minus 1, etc. So using this we can find sum of positive divisor. That's it. Okay. But what they have asked, only the canonical. If you do this much, that is enough. Okay. Now let us come to the next problem. Give the canonical representation of the following number 306. Okay. Now this is also same as that of the previous one, 306. So let us start with 2. 2 ones are 2. Again one reminder, 10. 2 5s are 10 and 2 3s are 6. Again if you start from 2, so 2 7s are 14, but 13 cannot be divisible by 2. Let us take 3. 3 5s are 15. 3 1s are 3. Again, so this can be divisible by 3 also. 3 1s are 3. 3 1s are 3. And what is the remaining is 21. So 21 can be divisible by 3 7 times. 7 3s are 21. So therefore this 17 cannot be divisible by any other number. 17 ones are 17 we can write. So therefore this 306 can be written as 2 to the power of 1 into 3 to the power of 2, 3 square into 17 to the power of 1. So this is the canonical representation of this number 306. Okay. So this can be written as usual, P1 to the power of alpha 1 into P2 to the power of alpha 2 into P3 to the power of alpha 3. So this is the canonical form of this number. Now let us come to the next problem. Give the canonical representation of the following number 5005. Now you cannot divide this from 2, 3 and 4. Let us start with 5. So 5 ones are 5, 0, 0, again 5 ones are 5. 1001 into 5 is equal to 5005. Again, so you can't divide from 5. Let us take 7. 7 ones are 7. 7 ones are 7. 10 minus 7 is 3. 301. 7 fours are 28. 7 fours are 28. So what is the remainder? Then we have remainder is 20. 30 minus 28 is 2 and 1 as it is. 7 threes are 21. So 143 into 7 is equal to 1001. Right. Now again this 143 can be divisible using 11. 11 13s are 13, 11 13s are 143. So this is 13 ones are. So therefore the canonical form of this is 5 to the power of 1 into 7 to the power of 1 into 11 to the power of 1 into 13. These are the factors. So therefore we can write 5005 as 5 to the power of 1 into 7 to the power of 1 into 11 to the power of 1 into 13 to the power of 1. That's it. This is the canonical representation for the number 5005. That's it. Hope you followed. Okay. Now let me take one problem on sum of all positive divisors of S of n is equal to P1 to the power of alpha 1 plus 1 minus 1 divided by P1 minus 1 into P2 to the power of alpha 2 plus 1 minus 1 by P2 minus etc. Pn to the power of alpha n plus 1 minus 1 divided by Pn minus 1 is a formula used to find the sum of all positive divisors. That what we did in the last class. Similarly, to find the number of positive divisor T of n, we are going to use, what is the formula is 1 plus alpha 1 into 1 plus alpha 2 into 1 plus alpha 3 etc. This is the formula. Now based on this, let me take one problem. Find the sum of positive divisors of 6498, 6498. Now let us come to the next problem. Find the sum of positive divisors of the following number 6498. Now let us represent this 6498 as the canonical form. Factorize this. So let us start with 2. 2 3s are 2 2s are 2 4s are 8, again 2 9s are 18. Let us divide with 3. So this is 3 10s are 30, and what is remaining is 249, 249. So again you can divide this, 3 8s are 24, 3 3s are 9. So 1083. Okay. Now again you can divide with 3. 3 3s are 9. What is remainder? 1 is a remainder, 183. 3 6 are 18 and 3 1s are 3. So 361, right. So we cannot divide this 361 with any other number. So we can write 19 19s are 19 19s are 361, and this is 19 1s are. So therefore this can be written as, that is 2 to the power of 1 into 3 to the power of 2 into 19 to the power of 2, 19 to the power of 2. So therefore 6498 can be written as 2 to the power of 1 into 3 to the power of 2 into 19 to the power of 2. If you observe carefully, this is of the form P1 to the power of alpha 1 into P2 to the power of alpha 2 into P3 to the power of alpha 3. So what is P1 here? P1 is equal to 2, P2 is equal to 3, and P3 is equal to 19. Alpha 1 is 1, alpha 2 is 2, and alpha 3 is equal to 2 again. This is also 2. Okay. Now, what is required to find the sum of positive divisors? So, the sum of positive divisors is given by S of n. S of n is equal to, you know the formula, P1 to the power of alpha 1 plus 1 minus 1 divided by P1 minus 1 into P2 to the power of alpha 2 plus 1 minus 1 divided by P2 minus 1 into P3 to the power of alpha 3 plus 1 minus 1 divided by P3 minus 1. This is the formula we are going to use. Now let me write the values of P1, P2, P3. What is P1, P2, P3? P1, P2, P3 is nothing but, here we have 2, 3 and 19, 2, 3 and 19, alpha 1, alpha 2 and alpha 3 is nothing but 1, 2, 2, 1, 2, 2. Okay. Now let us substitute here. Okay. Now let us substitute here. So sum of S of, what is the number? 6496, 6498 is equal to P1. P1 is 2 to the power of alpha 1 plus 1 is 1 plus 1 minus 1 divided by P1 is 2 minus 1 into P2. What is P2? 3 to the power of alpha 2. Alpha 2 is 2 plus 1 minus 1 divided by 3 minus 1 into P3. P3 is nothing but 19 to the power of alpha 3 is 2 plus 1. 2 plus 1 minus 1 divided by P3 is 19 minus 1. So this is equal to 2 to the power of 2 minus 1 by 1 into 3 to the power of 3 minus 1 divided by 2 into 19 to the power of 3 minus 1 divided by 19 minus 1 is 18. I'll simplify this. 2 square is 4 minus 1 divided by 1 into 3 cube. 3 3s are 9, 9 3s are 27 minus 1 divided by 2 into 19 cube. 19 into 19 into 19 is equal to 6859. 6859 minus 1 divided by 18. So what is this equal to? This is nothing but 4 minus 1 is 3 into 27 minus 1. 27 minus 1 is 26 divided by 2 into 6859 minus 1 is 6858 divided by 18. So if you divide, this is 13 2s are. So this is 18 into divisible by 381 times. So therefore the simplified answer for this is, I'll write here. So therefore this can be written as 3 into 13 into 381. 3 into 13 into 281. So I'll write once again, 3 into 13 into 381. So that is nothing but 13 3s are 39 into 381. If you multiply this, you are going to get the answer as 14859. 14800. Just simplify using a simple calculator. So just here, 4 minus 1 is 3, 27 minus 1 is 26 by 2, and 6859 minus 1 is 6858 divided by 18. So 13 2s are 26 gets cancelled. 3 into 13, 6858 divided by 18 is equal to 381. Multiply this. 13 3s are 39 into 381 is 14859 is the sum of all positive divisors of 6498 is 14859 is the sum of all positive divisors. This type of problems we did in the previous class also. Okay. Now let me take one more problem based on this concept. Right. Now let us come to the next problem. So find the sum of positive divisors. This is very important for 3 mark. It's a big problem. 39744. So we have to find the sum of positive divisors of this number, right? Now let us express this in terms of the canonical form. Represent this in canonical form. 39744. Now let us start with 2. 2 ones are 2, 1 is a remainder 19, 2 nines are 18, 1 is a remainder 17, 2 eights are 16, 1 is a remainder 14, 2 sevens are 14 and 2 twos are. So if you divide 39744 by 2, you will get 19872. Again with the same number 2. Let us start with the 2. 2 nines are 18, 1 is a remainder, again 2 nines are 18, again 2 threes are 6, 12 is a remainder, 2 6 are 12, 9936. Okay. Again divide by 2. Let us start with 2. 2 fours are 8 and 1 is a remainder 19, 2 nines are 18, 1 is a remainder 13, 2 6 are 12, again 16 is a remainder, 2 8s are. So 4968. Okay. Again divide by 2. 2 twos are 4, again 2 fours are 8, 16 is a remainder, then 2 8s are, then 2 twos, 2 fours are 8, 2484, right. So again you can divide from 2, 2 ones are 2, 2 twos are 4, 2 fours are 8, again 2 twos are 1242. Now again 1242 can also be divisible by 2. Let us divide by 2. 2 6 are 12, 2 twos are 4, 2 ones are 2, 621. This 621 cannot be divisible by 2. So I will divide this 621 by 3. So that is 3 twos are 6, 0, 3 sevens are 21. So if you divide by 3, 3 23s are 60 and 21 is a remainder, 3 sevens are 21. So 207 into 3 is 621 you will get definitely. Now if it is possible, divide from 3. Is it possible to divide from 3? 3 6 are 18 and 2 is a remainder 27. 2 3 9s are 27. Okay. Again you can divide with 3. 3 2s are 3 3s are. Again is it possible to divide by 3? Now you cannot divide 23 by 3, right? Therefore this can run as 23 into 1. So therefore the canonical form of this is 1 2 3 4 5 6. So 39744 is equal to 2 to the power of 1 2 3 4 5 6, 2 power 6 into 3 to the power of 1 2 3, 3 to the power of 3 into 23 to the power of 1. Okay. Now simplify this. So this can be written as, I will go to the next page. Therefore 39744 is equal to 2 to the power of 6 into 3 to the power of 3 into 23 to the power of 1. Okay. This is P1 to the power of alpha 1 into P2 to the power of alpha 2 into P3 to the power of alpha 3. Okay. Right. Now this is the canonical form of 39744. So 39744 can be written as 2 power 6 into 3 power 3 into 23 to the power of 1. Now what is the value of P1 here? P1 is equal to 2, P2 is equal to 3 and P3 is also equal to 23. Similarly alpha 1 is 6, alpha 2 is equal to 3 and alpha 3 is equal to 1. Now what is the formula we are going to use? S of n is equal to P1 to the power of alpha 1 plus 1 minus 1 divided by P1 minus 1 into P2 to the power of alpha 2 plus 1 minus 1 divided by P2 minus 1 into P3 to the power of alpha 3 plus 1 minus 1 divided by P3 minus 1. Substitute here. So, sum of the divisors of 3, 9, 7, 4, 4 can be written as P1. What is P1? 2 to the power of alpha 1 is 6 plus 1 is 7 minus 1 divided by P1 is 2 minus 1 into P2. What is P2? 3 to the power of, what is alpha 2? 3 plus 1 is 4. 3 to the power of 4 minus 1 divided by, what is P2? P2 is equal to 3 minus 1 into P3. What is P3? P3 is equal to 23 to the power of alpha 3. Alpha 3 is 1 plus 1. 1 plus 1 is 2 minus 1 divided by P3 is 23 minus 1. Simplify this. That's it. So, this is equal to 2 to the power of 7 kilometers, 2 to the 4, 4 to the 8, 8 to the 16, 16 to the 32, 32 into 2 is 64 into 2 is 128. This is 128 minus 1 divided by 1. If you want, you can check 1, 2, 3, 4, 5, 6 and 7. 1, 2, 3, 4, 5, 6, 7. 2 to the 4, 4 to the 8, 8 to the 16, 16 to the 32. 32 into 2 is 64 into 2 is 128 minus 1. 3 to the power of 4. 3 into 3 into 3 into 3. 3 3s are 9, 3s are 27, 3s are 81. Minus 1 divided by 3 minus 1 is 2 into. So, 23 square is 529. 529 minus 1 divided by 23 minus 1 is 22. Now, simplify this. This can be written as, right here, 128 minus 1 is 127 into 81 minus 1 is 80 divided by 2. 80 divided by 2 into 529 minus 1 is 528. 528 divided by 22. So, this can be written as 127 into 80 by 2 is 40 into, if you divide 528 by 22, so it will be divisible by 24 times. Now, multiply this, 127 into 40 into 24. So, if you simplify this, the answer you are going to get is 121920. That's it. So, therefore, the sum of all divisors, positive divisors of 3, 9, 7, 4, 4 is equal to 121, 920. That's it. 121, 920 is the sum of all positive divisors of the given number 39744. That's it. Okay. Hope you followed. So, these are few problems based on the canonical representation and some of the positive divisors and the number of positive divisors. So, that's all regarding today's session. Let us meet with the different concept in the next class. Thank you very much.